All right, let's jump right into this explainer. Today, we're unpacking what is easily Elon Musk's most ambitious physical project to date. We are looking at a massive, multi-layered endeavor designed to completely rewrite the global artificial intelligence supply chain from the ground up, and then, eventually, blast the whole thing into low Earth orbit. We're not just talking about building faster computers here, this is about fundamentally reorganizing how AI compute is physically produced, basically marrying semiconductor manufacturing with heavy-lift rocket logistics.
To really grasp the sheer scale of this, you have to look at the price tag. $119 billion. Yeah, you heard that right. This is the potential total investment behind a massive project known as TerraFab. It's an epic joint venture uniting Tesla, SpaceX, xAI, and reportedly even Intel to build the ultimate chip manufacturing operation down in Texas. We're talking about a proposed site spanning roughly 100 million square feet. To put that into perspective, that's the equivalent of 15 pentagons. But, to understand why Musk is attempting something this incredibly capital intensive, we have to look at where the global chip market is sitting right now. So let's look at the gap between what we have and what TerraFab wants to achieve. Right now, the entire global semiconductor industry puts out roughly 20 gigawatts of capacity per year. Musk's goal? 1,000 gigawatts. That is 1 terawatt. We're talking about a 50-fold increase over what the rest of the planet is currently doing, combined. It is absolutely staggering.
See, Musk is looking at the traditional semiconductor industry and saying, look, you're only producing about 2% of the computing power my companies are actually going to need in the coming years. Now, he definitely plans to keep buying every single chip he can get his hands on from traditional suppliers like TSMC and Samsung, but those guys, they have a maximum expansion rate they're comfortable with. And that rate is just vastly slower than the explosive compounding demand for AI hardware that Tesla, xAI, and SpaceX are forecasting. He's essentially laying it out. We either build the TerraFab or we literally don't have the chips. So how exactly do they plan to build them faster? Well, the terrestrial solution starts with a massive advanced technology fab in Austin. The idea is to compress the traditional, highly fragmented global supply chain into a super-fast, recursive loop. Normally, these 5 steps, design, mask, fabricate, package, and test, happen across entirely different companies, often on entirely different continents. TerraFab aims to do the whole shebang under one roof. By keeping that design-to-silicon loop in a single building, engineers can get instant feedback. They can iterate chip designs in a matter of days rather than months. Okay, but here's where things take a really wild turn. Where is all this terawatt-scale computing power actually going? You'd probably assume it's all for massive data centers here on Earth, right? Nope. Only a fraction, about 20%, is meant for terrestrial applications. The vast majority, a massive 80%, is literally destined for the stars. Let's break down that 20% earthly chunk first. This capacity is hyper-focused on A15 and A16 edge inference chips. These are the brains that will power Tesla's full self-driving vehicle fleets. But honestly, more importantly, they're meant to power Optimus humanoid robots. Musk envisions a future where his companies are churning out between 1 and 10 billion humanoid robots per year. To hit that kind of scale, you need an industrial-scale pipeline of inference hardware that just simply does not exist today. But that brings us back to that 80% slice, which poses a massive, almost existential logistical question for the future of AI computing infrastructure. Where exactly do you put a 1 terawatt data center? To give you an idea of how crazy that is, the entire US electricity generation capacity is only about half a terawatt. The reality is, Earth is basically topped out. We simply don't have the available land, the rapid permitting speed, or the grid capacity to support this much power cleanly. As Musk pointed out, nobody wants the thing in their backyard. Expanding power generation on Earth is getting exponentially harder and way more expensive. And that is exactly why the TerraFab narrative shifts dramatically, away from the ground in Texas and straight up into the vacuum of space. The grand plan is to launch AI data centers directly into low Earth orbit. Up there, they can just soak up unfiltered, continuous solar power 24/7. No weather delays, no atmospheric interference, no seasonal changes. Musk actually frames this within the Kardashev scale. He suggests that launching a 1 million satellite constellation to harvest the sun's energy directly in space is a necessary step to push humanity toward becoming a Type II civilization, one that can harness the full energy output of its host star. And hey, this isn't just some sci-fi pipe dream. Actually, SpaceX is actively laying the foundation for an orbital energy grid right now. They're already scaling their orbital solar capacity exponentially.
Generation 1 of Starlink harnessed about 10 megawatts. Then Gen 2 scaled up to 100 megawatts. And the projected Gen 3, that pushes straight into 1 gigawatt territory. Which brings us to the actual hardware they plan to deploy, the SpaceX AI-1 satellite. You can think of this first-generation orbital data center as a flying, high-powered server rack designed to deliver roughly 150 kilowatts of peak power. It smartly reuses proven Starlink V3 solar arrays and thermal systems, it talks to other satellites via high-speed laser links, and it houses the equivalent of an NVIDIA GB300 class compute rack. Keep in mind, these aren't on-demand cloud rentals for everyday consumers. These are heavy-duty compute nodes for massive committed tenants like xAI and Anthropic.
But, and there's always a big but with space, deploying these brings up a massive engineering complication. We intuitively think of space as freezing cold, right? Well, a vacuum is actually a near-perfect insulator. It's essentially a giant thermos. Because of the Stufan-Boltzmann law, you can't just slap a fan on a hot AI chip in space. Heat has to be radiated away entirely as infrared light. So dissipating the immense heat generated by AI chips isn't just tricky, it's a literal physics wall. Down here on Earth, it's easy. We just blow moving air or pump cold water over servers to whisk the heat away. Super efficient. But in orbit, to dissipate just 1 single megawatt of heat and keep those electronics stable, you need radiator fins roughly the size of 4 tennis courts. Suddenly, the size of your satellite isn't dictated by the computer chips at all. It's dictated entirely by the cooling fins. This radiator-to-compute ratio becomes a massive, fundamental architectural bottleneck.
Oh, and if heat wasn't enough, the hostile environment of space throws another massive curveball: total ionizing dose. Space is absolutely swimming in highly energetic particles from the sun and cosmic events. Standard data center class GPUs, they are not radiation hardened. That means they're highly susceptible to single event bit flips and cumulative radiation damage, which is going to significantly shorten their operational lifespan in orbit compared to a safe terrestrial server farm. So let's do the math here, because it is staggering. When you factor in the power limits, those massive radiators you need, and the harsh radioactive environment, just to match the sustained compute of one standard 1 gigawatt Earthbound data center, you would need up to 8,300 of these AI-1 satellites. To put that into perspective, that's close to 2/3 of every single Starlink satellite SpaceX has launched since 2018, just to equal 1 data center on Earth.
And to actually reach Musk's ultimate terawatt goal in space, we're talking about delivering roughly 10 million tons of AI hardware into orbit every single year. This is the ultimate reality check for Terafab's orbital ambition. It means the rules of the AI game are shifting from a purely digital problem to an intensely physical one. It becomes a problem of sheer brute force mass transport.
So the scarce resource in the AI arms race might not even be silicon anymore. It might not be TSMC's fabrication schedules or even Earth's power grid. It's the physical logistics and heavy lift launch capacity needed to blast this infrastructure off the planet. Pulling this off requires an expanded gigasat factory in Bastrop, just churning out satellites, plus hundreds of Starship rockets operating on a relentless, round-the-clock, rapid reusability launch cadence.
Which leaves us with a truly fascinating, paradigm-shifting question to end on. As we scale toward this terawatt future, and the physical limits of Earth's land and power grid literally push our computing into the stars, are we going to find that the real bottleneck to artificial intelligence isn't the software, but simply how fast we can build rockets to leave the Earth? It's a staggering thought, and it completely reframes the entire AI race. Thank you so much for joining me on this explainer. Keep questioning the bottlenecks and keep learning.